The National Electrical Code, or NEC, Section 210.12 addresses arc fault circuit interrupter, or AFCI, protection. A proposal was submitted to add an exception to this section. The proposed exception stated that in existing dwelling units where outlets are added to existing branch circuits where AFCI was not present, AFCI protection for such outlets would not be required. The reasoning behind this proposal was that the current text complicates simple additions to older homes. Before AFCI requirements, multiwire branch circuits were often used to supply bedrooms and other circuits. As these older homes are upgraded with ceiling fans, receptacles for fixed televisions, and so on, installers face difficulties due to the lack of readily available two-pole AFCI breakers for different brands of load centers in these older homes. The proposal argued that currently, installers might be forced to purchase a new load center capable of supporting a compatible two-pole AFCI breaker, passing this cost on to the consumer. This could lead to unlicensed or uninspected work being done for lower costs. The proposal suggested that the uninspected work created by the restriction in this section poses a greater threat than not having the AFCI protection in the first place. It was also mentioned that as AFCI technology evolves, this exception could be removed to enhance safety in existing dwellings. The proposal included an attached online conversation highlighting some of the unexpected consequences faced by electrical contractors. However, this proposal was rejected. The comment stated that the proposal inadvertently allows the addition of unprotected outlets to protected circuits. AFCI protection is required by 210.12 for all 15 and 20 ampere branch circuits supplying outlets and dwelling units. Another proposal was accepted in part. This revised 210.12b to allow for existing multiwire branch circuits by limiting the exception to dwelling unit additions of 15 and 20 ampere branch circuits supplying outlets. This requires the new branch circuits for dwelling unit additions to be protected by AFCIs. In summary, the discussion revolves around the complexities of implementing AFCI protection in older homes with existing multiwire branch circuits. The original proposal sought to create an exception to avoid the high cost and potential for uninspected work, but this was rejected due to safety concerns. A subsequent revision was accepted in part. This limits the exception to dwelling unit additions of 15 and 20 ampere branch circuits supplying outlets, ensuring that new branch circuits are protected by AFCIs. Arc fault circuit interrupters are designed to protect against fires caused by arc faults, which are dangerous electrical conditions that can occur in damaged or degraded wiring. These devices work by monitoring the electrical current and quickly shutting off the circuit when an arc fault is detected. This helps to prevent the arc fault from igniting nearby materials and causing a fire. There are several types of AFCIs available, including branch circuit AFCIs and combination AFCIs. Branch circuit AFCIs protect against arc faults in the branch circuit wiring, while combination AFCIs provide protection against both branch circuit arc faults and series arc faults. Series arc faults occur when there is a break or loose connection in a single wire, while branch circuit arc faults occur between two different wires or between a wire and ground. The National Electrical Code requires AFCI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. This requirement helps to improve electrical safety and reduce the risk of fires. When installing AFCIs, it is important to follow the manufacturer's instructions and the requirements of the National Electrical Code. It is also important to test the AFCIs regularly to ensure that they are functioning properly. AFCI should be tested at least once a month by pressing the test button on the device. If the AFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to AFCIs, there are other electrical safety devices that can help to protect against fires and electrical shocks. These devices include ground fault circuit interrupters, or GFCIs, and surge protectors. GFCIs protect against electrical shocks by monitoring the current flow in a circuit and quickly shutting off the circuit when a ground fault is detected. Surge protectors protect against damage from power surges which can occur during lightning storms or other electrical events. It is important to use all of these electrical safety devices to protect against fires and electrical shocks. By following the requirements of the National Electrical Code and using the appropriate safety devices, homeowners can create a safer electrical environment for themselves and their families. In new construction, AFCI protection is generally straightforward to implement. However, in existing homes, especially older ones, retrofitting AFCI protection can present challenges. One common challenge is the lack of a neutral wire in some older wiring systems. AFCIs require a neutral wire to function properly. In such cases, it may be necessary to rewire the circuit to include a neutral wire, which can be a significant undertaking. Another challenge is the presence of shared neutral wires in multiwire branch circuits. AFCIs are designed to protect individual circuits, and sharing a neutral wire can interfere with their operation. In these situations, it may be necessary to separate the multi-wire branch circuit into individual circuits, each with its own neutral wire. The cost of AFCI protection can also be a factor, especially when retrofitting an entire home. AFCIs are more expensive than standard circuit breakers, and the cost of installation can add to the overall expense. However, the benefits of AFCI protection in terms of fire prevention outweigh the costs. When considering AFCI protection for an existing home, it is important to consult with a qualified electrician to assess the wiring system and determine the best approach. The electrician can identify any potential challenges and recommend solutions that meet the requirements of the National Electrical Code. It is also important to choose AFCIs that are compatible with the existing electrical panel and wiring system. There are many different types of AFCIs available, and not all of them are compatible with all electrical systems. The electrician can help to select the appropriate AFCIs for the specific application. In addition to the technical challenges of implementing AFCI protection in existing homes, there are also some code compliance issues to consider. The National Electrical Code is updated every 3 years, and the requirements for AFCI protection can change from one edition to the next. It is important to ensure that the AFCI installation meets the requirements of the current edition of the National Electrical Code. The local electrical inspector can provide guidance on code compliance issues. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to reflect changes in technology and safety practices. The NEC is not law, but it is widely adopted by state and local governments. This makes it a legal requirement. Compliance with the NEC is essential for ensuring the safety of electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes requirements for specific types of occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC uses a numbering system to identify each section. For example, Section 210.12 covers AFCI protection in dwelling units. Understanding the structure of the NEC is essential for navigating the code and finding the information you need. The NEC is a complex document, and it can be challenging to understand all of its requirements. However, there are many resources available to help you learn more about the NEC. These resources include training courses, seminars, and online forums. It is also helpful to consult with a qualified electrician or electrical inspector. They can provide guidance on specific code requirements and help you ensure that your electrical installations are compliant with the NEC. The NEC is an essential tool for ensuring electrical safety. By following the requirements of the NEC, you can help to prevent fires, electrical shocks, and other hazards. It is important to stay up to date on the latest edition of the NEC and to consult with qualified professionals when you have questions. The process of proposing changes to the National Electrical Code is an important part of ensuring that the code remains relevant and effective. Anyone can submit a proposal to change the NEC, including electricians, engineers, contractors, and manufacturers. The proposals are reviewed by code-making panels, which are composed of experts in various fields of electrical safety. The code-making panels consider the technical merits of the proposals and their potential impact on safety. They also consider public comments on the proposals. After reviewing the proposals and comments, the code-making panels make recommendations to the NFPA Standards Council. The Standards Council makes the final decision on whether to approve the changes to the NEC. The process of proposing changes to the NEC is transparent and open to the public. This ensures that all stakeholders have an opportunity to participate in the development of the code. The AFCI requirements in the NEC have evolved over time as the technology has improved and the understanding of arc fault hazards has grown. The first AFCI requirements were introduced in the 1999 edition of the NEC. These requirements applied only to bedroom circuits in dwelling units. Over time, the AFCI requirements have been expanded to include other areas of the home such as living rooms, dining rooms, and hallways. The NEC now requires AFCI protection for most 15 and 20 ampere branch circuits supplying outlets in dwelling units. The expansion of the AFCI requirements reflects the growing recognition of the importance of arc fault protection in preventing fires. Studies have shown that AFCIs are effective in reducing the number of fires caused by arc faults. As AFCI technology continues to improve, it is likely that the AFCI requirements in the NEC will continue to evolve. One area of ongoing development is the development of AFCIs that are more resistant to nuisance tripping. Nuisance tripping occurs when an AFCI trips due to a non-hazardous condition, such as a momentary surge in voltage. Nuisance tripping can be annoying and inconvenient, and it can also lead to homeowners disabling their AFCIs. Manufacturers are working to develop AFCIs that are less prone to nuisance tripping while still providing effective arc fault protection. Another area of development is the development of AFCIs that can be used in multiwire branch circuits. Multiwire branch circuits are commonly used in older homes, and they can present challenges for AFCI protection. Manufacturers are developing AFCIs that are specifically designed for use in multiwire branch circuits. These AFCIs are designed to protect each individual circuit in the multiwire branch circuit while still allowing the circuits to share a common neutral wire. The use of multiwire branch circuits can pose challenges for AFCI protection because the shared neutral wire can create a path for current to flow between the circuits. This can cause the AFCI to trip even if there is no arc fault on the circuit that it is protecting. To address this issue, manufacturers have developed AFCIs that are designed to detect arc faults on multiwire branch circuits without being affected by the shared neutral wire. These AFCIs use advanced sensing technology to distinguish between arc faults and normal current flow. When installing AFCIs in multiwire branch circuits, it is important to follow the manufacturer's instructions carefully. It is also important to ensure that the wiring is properly installed and that all connections are tight. Loose connections can create arc faults and cause the AFCI to trip. In addition to the technical challenges of implementing AFCI protection in multi-wire branch circuits, there are also some code compliance issues to consider. The National Electrical Code requires that AFCIs be installed in accordance with the manufacturer's instructions. It also requires that the AFCIs be tested regularly to ensure that they are functioning properly. The local electrical inspector can provide guidance on code compliance issues related to AFCI protection in multi-wire branch circuits. AFCIs are an important safety device that can help to prevent fires caused by arc faults. When installing AFCIs, it is important to follow the manufacturer's instructions and the requirements of the National Electrical Code. It is also important to test the AFCIs regularly to ensure that they are functioning properly.